Hi, I'm doing Paul McWhorter's Arduino R4 lessons, and at the moment Paul's showing us how to use Python to control an Arduino. Now, in the chat session for lesson number 67, I said I'd do a quick video, well, my videos are never very quick, to show how you can do it using Firmata and also LoRa, but not at the same time. So this is I'm starting off with the Firmata bit, and I've previously done a video on Firmata, and it's called Using Python to Control an Arduino, I think, and I'll leave a link to that so I don't have to explain what's going on. Now, what you do is, with your Arduino, I'm actually using an Arduino 3 for this because my Arduino 4 is tied up with other things, and it's a lot easier. And I can make, if anyone's interested, I can make a video for using the Arduino R4, but it's quite a lot of work and I won't bother if no one's interested. So here we go. First of all, you go on to File and Examples and Firmata, and down there's a thing called Standard Firmata. So you get that into your IDE and you upload it onto your Arduino, and it will just sit there waiting for someone to do something. I'm using Paul's PicoW lesson number 115 to generate the colours using the three sine waves, one for red, green and blue, and I've just amended it to use Firmata instead. So as his program uses a client server relationship, I'm getting rid of everything like that. So I'm getting rid of that line, I'm getting rid of those lines, and down here, down here, down here, I'm getting rid of that lot. Then this is my version. So I'm replacing those lines with that. Now that is just importing Firmata, setting up which board, and for this one. And it's really annoying that my R3 is on COM4 and my R4 is on COM3, but I can't do anything about that. And that is, as explained in my Firmata video, is how you set up the pins. It's digital, pin number 9 for red, and PWM even. And that line there is just to allow for the fact that my RGB LED has got a common anode rather than a common cathode. So we come down here, right, this is all I've put in. Firmata wants the values for an RGB LED, or an LED anyway, to be in the range 0 to 1, which is why I've taken current red and divided by 255. And if it's a common anode, that will be true, i.e. 1, so it's 1 minus that and the absolute value. And if it isn't a common anode, it's 0 minus that, the absolute value, which is the same as it was in the beginning, if you get my drift. So I'm just writing to R, writing to G, writing to B, and that is it. So we will run this program. May as well close that. Now that is on because it's a common anode, so it will just sit there until I give it any power. Right, so we'll run this program, and there, that is Paul's little thingy, and the values are taken from there, and you can see the values are being passed to that. And if I turn down green and I turn down red, it's just going blue, going through all the values of blue, bluer, 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 then it's getting less blue, and I can turn blue down and I can turn red up, and everything works. And as you can see, it is so much simpler, because all that you have to do is on the Python side. You just let someone else look after what's happening on the Arduino side. So that's my Firmata solution, and I'm coming on to, and as I said, if anyone's interested in the R4 version, I will do a video, but I'm a bit busy. Now for the LoRa version, I don't know if anyone will be interested in it apart from Lee, but I will stop there and come back. Now going on to LoRa. Now LoRa, as I'm sure everyone knows, stands for long range, and it's a good way to be able to connect two devices over a long range without Wi-Fi and using very little power. So you can connect a couple of picos together, and they don't even need to be pico Ws, but today I'm using two Arduinos. So this is the module that I bought. I bought two of them to begin with, and they I bought them for two reasons. One, they're ready soldered, because I didn't want to be bothered with that, and they were made in Taiwan, so I thought that might guarantee better quality rather than China. And so I started off and I was connecting two picos together, not pico Ws, and the trouble was I was doing it via Thonny, and on Windows I couldn't get it to connect to both of them at once in Thonny. I think you can on a Mac, but you can't in Windows. So it was being a bit blind. You had one program running on one and one program running on the other, and you could only see one end. So if something went wrong, you'd have to think, I'll swap them over and have a look to see what's happening. But there is a better way. So after I got that working, I thought I want to connect LoRa to my PC. So I bought this, and it came with two of them, and it's a USB to TTL UART serial converter. I can read, and it means that you can plug your LoRa module into one end and plug the other end into your USB port on your PC, and you can have two connected at the same time, which was jolly good. And I will just show you what it is. I'll get my camera. I don't need that at the moment. Camera. There. So I have the LoRa module, and it's got 5 pins, and the pins are ground, TXD, RXD, there's a reset that you don't use, and a VDD. And on the other end you have 3.3 volts, TXD, RXD, ground, and 5 volts. Now you don't use the 5 volts, so what you do is you connect ground to ground, 3.5 to VDD, TXD to RXD, and RXD to TXD, and everything ought to work. So plug it in the right way round. Now, do I have two lights on? I have two lights on, that's lucky. And you can go into Device Manager, and down here under Ports COM LPT, there we have them. One is on COM 11 and one is COM 9. So next thing to do is to go into the Arduino IDE and open up a new sketch and connect to whichever one. I'm connecting to COM 9 there, and you don't need a program, and you open up the monitor there, serial monitor. I'll get rid of that, not interested in than that anymore. 0 monitor. So this is when you can start communicating with your LoRa module. I've reset it to factory settings, so I'm starting at the beginning. If you just go AT, it will go OK, and you think, oh, good, that proves it's working. So you want to set up the address of this one, AT, and then it's AT plus. Oh, I forgot to say, we will go back here. Or we won't. Why won't you connect? This is very annoying. Hurrah! It worked. I was doing something wrong. There's also, I'll leave the link for this, there's a web page for REAX, and it describes various things about it, but what is also useful is the LoRa at command guide, which tells you everything that you need to know. I haven't used all of these commands because I don't need them. So I'll leave the link for that as well. Right, back to where we were. Right, so first thing, you want to set the address of your LoRa module. So it's easiest if you have caps lock on. AT plus address equals, and I'm up to 4 for this one. And it just goes OK, and then you go AT plus network ID equals, oh, I'll use 5 I suppose, because they have to be on the same network, as otherwise they can't communicate. Then if you want to find out what you've done, you can go AT plus address, and instead of the equals, just put a question mark there. It tells you what it's set to. Then if we go AT plus band, which is the frequency, and because you're on free, you know, without needing a license frequency, it varies in different countries. So in Europe it's 868 1 2 3 4 5 6 zeros. In America and Australia it's 915 and 6 zeros, and I've no idea about other countries. Right, set that, and then the last thing you want to do, it defaults to a baud rate of 115/200, and I think I would really prefer, because it tends to work with everything, baud rate of 9600. So you go AT plus IPR equals 960. And here it doesn't just tell you OK, it actually tells you what you've set it to. And the reason for that is if you go AT, you get gibberish. So that's a reminder there that you need to set the baud rate to that there. And now if you go AT, it's got an OK there. So that is about all you need to do. And then you go on to the other one. Again, you do new sketch and open serial monitor, and here it would tell you that it's 11. So I will go AT just to see if it's working. Yep. So this time it's AT plus, I could have just copied and pasted from the other side I suppose, AT plus address equals, I've got a sticker on it, 2 AT plus network ID equals 5, 80 plus band equals 868,000,000, and then 80 plus IPR equals 9600. And again, gibberish. So I'll just go 80 again. Yeah, there's an OK. I'll clear that and clear that. Now, trying to communicate between them. You go AT, all the commands start AT plus. AT plus send equals. Now you're sending it to, that was 2, wasn't it? 2. And then you have to put in the length of the string that you're going to be putting in. So 4, comma, what will happen? Will this work? Yes, look, it says plus receive equals, and that 4 is because it came from address number 4, help, and then, oh, that's to do with speed. I'm not using that at the moment. And then you can do it again, and you can use up arrow here, so you can go 7, comma, and you can mix case, for example. Yeah, and you can, whoops, you can put a comma in the middle if you wish. Yeah, did that work? No, don't know what I did. What did I do? Maybe you can't put a comma in the middle. That's very odd. I could have sworn you could put a comma in the... Ah, it's too long. It is too jolly long. It tells you what the errors are. That error didn't mean, you stupid woman, you put a comma in the middle. That was, you stupid woman, you said it was 7 long and it was 8. And so you've got that. And you could go on to the other one and hope this works. 80 plus send equals which one was that? 4, comma, I don't know, 8, comma, and test, and hopefully you can put a space in the middle. I tried a comma in the middle. Yeah, there we go. Received from address to 8 test blah 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 blah. So that is really the basics of everything you need. But the trouble is, other people could be using the same network ID and the same addresses, and they could be sending things that you don't want. Supposing in the thing that I'm going to be doing, I'm expecting an RGB colour, so it would be up to 3 numbers, comma, up to 3 numbers, comma, up to 3 numbers, and someone else using the same network ID could be sending total rubbish. So there's something where you can go 80, which one am I on? Oh, it doesn't really matter which one I'm on, plus, and it's C pin. If I just go question mark, it goes no password. So you can set the password. So you go C pin equals, and then this is 2, 4, 6, 8, up 8 digits, no, 8 characters for, how many is that? One, I'll start again. 1, 2, 3, 4, 5, 6, 7, and then do that. Is that too many? Don't know if it's too, it's too many. Right, like that. Okay, it says. So now if you do password, right, it tells you what the password is. So you send that again, and look, if you look at what you received over there, it's kind of the same, but it's been messed about a bit, and you think, So if you change the password of this one to AT plus, I mean, password is kind of a bit, I don't call it a password, I think it would be more like your decoding options, because it isn't a password, because you can still receive the data, it's just you receive jumbled up data. So it was 1, 2, 3, 4, 5, 6, 7, 6, like that. And now we'll try sending it. There, worked wonderfully. And the password stroke decoding thing is 8 characters between 00000 ending in a 1 up to FF. And that's about all you need to do. I mean, it doesn't stop the data getting to the other side, it means that it's just the wrong data. Now I wonder, if you go, I haven't tried this before, if you go setting it all to zeros, and then you see, oh, I haven't done, whoops, right, I haven't checked what it is here, so doing, what does it say? Oh, now that is strange. I don't know whether that means that it is actually that, or whether it has no password, because I don't know how to set it back to having no password unless you do it with all zeros. This is to be explored, investigated. So that's just about all you need to do, and I'm going away now, and then I'm going to show it running on something running on 2 Arduinos. So right, so just to show that you can actually do something with LoRa and use LoRa to connect 2 Arduinos so they communicate together, I've written a couple of programs. Now this one on the right is on the Arduino R4, and all it does, oh, I don't have a button anymore, that shouldn't be there and that shouldn't be there, so I'm starting it the LoRa and the serial both on the same baud rate, and I'm using software serial.h to do everything with it. So I'm just looping through and sending string for, so that's address 3, the string is 7 long, and then that's the RGB for green, and then I'm doing mauve, which is why there's a 9 there, because the string's longer. Then it's red, cyan, white and blue, and that's all it does. And I think perhaps I made a mistake having the baud rate at 9600 because it seems a bit slow, but who cares, this is just a demonstration. And on the other side, did I say that was on the R4? On the R3, because I've only got one R4, I'm using software serial.h again, and it's I've got a string, I'm defining the pins, starting up LoRa, and when I get something in, the incoming string from LoRa is kind of in format plus RCV, comma 2, I think, because that's where it came from, then the length, and then this is why I'm doing my very lame dividing up of the thing. If it's the third comma, then I'm writing out red, otherwise I'm writing out green, otherwise I'm writing out blue, otherwise I don't really care about the rest of it. And I just want to show that it does work. So if I'm just going to show the camera, doink, resetting that, and they're both running at the moment. So there we go, blue, green, mauve, don't know, cyan, white, back to blue, and that's just to show that it will do it. And I can't stop this apart from going like that because the lights are off.